Okay, Assalamualaikum and greetings to all of you. So today I will continue cylindrical coordinate in triple integral. In triple integral. Then so in cylindrical coordinate we have x equals to r cos theta, y equals to r sin theta, and then we have z equals to z, and the element dv in the integration will be r dr d theta dz. Okay. So let's say we have a point here, so we have to change in r theta z. So say I extend this point, so this is the r, always from the pole, and then the angle from x, this is x, y, z, it's x from here to here, theta, anti-clockwise. R must be from the pole and outwards. Okay, R, so this is R, and always positive, and not necessarily must start from 0. Okay, if the two surface bounded, you're focusing on the, say we're focusing in this region, so your new R will be from this point to this point. Okay, so R done. Your theta must be always anti-clockwise. Direction. Okay, Z is BZ. Z. Okay. Let G theorem. Let G be a solid with upper surface Z, G2 r theta, and lower surface will be G1, also function of r theta. Let R be the projection of the solid on the xy plane. Then if the function f r theta and z, function of r theta and z, is continuous on R, that is projection of solid on the xy plane, we have triple integration of G under solid G, f r theta z dv will be R integration G1 r theta to G2 r theta f r theta z r dz dr d theta. Okay. 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 Example 1. Use the cylindrical coordinate to evaluate the 3 to 3. Negative 9 minus x squared, this is positive 9 minus x squared, and then 0 to 9 minus x squared minus y squared, x squared dx dz dy dx. Remember this will return to r dr d theta. Okay, that will remain. So first, how to sketch. So see the region where z is in between 0 to 9 minus x squared. So z equals to 0 is the lower bound, and z equals to 9 minus x squared minus y squared. So when z equals to 0, you'll get 9 minus x squared minus y squared equals to 0. So x squared plus y squared equals to plus minus 3 squared. So you have circle with radius 3. In 3D, we'll get a cylinder. Okay. Okay, but this is from 0. Then you have y. Y is from negative square root 9 minus x squared to positive 9 minus x squared. So y is equals to plus minus square root x squared, and we squaring both sides, we have x squared plus y squared equals to 9, which is plus minus 3. Okay, what else? Then you have your x is between negative 3 to 3. Okay, so you have a circle with radius 3. Okay. So this is for yx. Okay, how about for z and y? How about z and y? If z equals to 0, then you have a circle with radius 3. Okay. If x equals to 0, if the x equals to 0, you have z equals to 9 minus y squared. Okay. If the y equals to 0, you have z equals to 9 minus x squared. So this is negative x minus 0 squared plus 9. So you have a minimum curve because this is negative, and then the maximum curve because this is a negative, and then you have the maximum point is 0, 9. So somehow it's like this. When x is 0, z equals to 9. When z equals to 0, x equals to 9 plus minus 3. Okay, somehow if we draw the graph, it will look like the bottom part yx will be circle. So how to draw? The upper part, this is zx or zy will have a parabolic. Also for x, this is zx and this is zy. Okay, so this is your region now. this is 9, this is 3. Okay, now if you want to find limit for r, or bounds for r or for theta, look in xy plane. Okay, so limit for r for sure from 0 to 3, and then limit for theta, remember your theta must be anti-clockwise direction from the positive x, here to here, which is 0 radian to 2 pi. This is 3. Now for z start from 0 until here. So remember, we don't want x, we don't want y, we want only r and theta. Cos, sine is okay. So now this 9 minus x squared minus y squared can be written as 9 minus x squared plus y squared in bracket. So this is 9 minus r squared. So your z is from 0 to 9 minus r squared. Remember, for polar coordinate, x equals to r cos theta, y equals to r sin theta. Okay, x squared plus y squared equals to r squared. Okay, tangent theta will be y over x. Okay, remember this. In 3D, this is positive x, positive y, positive z. So they will move like this. Theta. Okay. Let's say I have a point here that is parallel to this. Your r should be outwards. Okay. So now you can integrate easily. We have triple integral, and then the question is integration of x squared. So x squared, we don't want x squared, so x is r cos theta, so r squared cos squared theta, r, what else, r, and then dz dr d theta. Okay, so this can be written as r cubed cos squared. Then the limit for z is 0 to 9 minus r. The limit for r is for 0 to 3. Limit of theta from 0 to 2 pi. Okay, so you can integrate this, and then you will get 243 over 4 pi. Okay. Remember, you cannot integrate this directly. You have to use the trigonometric identities. Okay, next, B. I think number 2, question 2. Example 2, question 2, where the limits are given. 2a. Okay, example 2a. They give you the limit from 0 to 1, the outermost limit, and then the middle one will be 0 to 1 minus 1 squared, and then you have the innermost is 4 minus square root 4 minus x squared minus y squared, z dz dx dy. Okay, remember this will return to r dr d theta. Z is remaining. Okay. Okay. First, sketch the limit. Your y is from 0 to 1. Okay. And then your x is from 0 to 1 minus y squared square root. So I think I should write the same pattern. The y is from 0 to 1. Then the z is from 0 to 4 minus x squared minus plus y squared. Okay. So if I draw this 0 to 1, this is x, this is y. 0 to 1, so I just cut 1 equals to 1. And then we have x 0, which is here. Okay. And then x equals to square both sides, we get x squared plus y squared equals to 1. So because of they only consider the positive part, and only for x0 and y equals to 1, so only this circle. Usually we have here, here and here. Okay. Sorry, I think this is wrong circle. It's correct, but I think I have to draw nicely. Somehow we draw a circle like this. Then we have another half and another half and another half. Quarter, 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 quarter. So we don't need this because the region is not considered here. So we just choose this region. Okay, from here you can determine your R. So your R is from 0 to 1. Limit for R. So limit for theta. Theta will be from positive axis to here. Will be pi over 2. Done. For Z will be 0 to 4 minus R squared. Okay. So without drawing the full diagram also you can find the limit. So if you insist to draw, you can, no problem. So we already know this is a circle, this is a circle. For Z, Z equals to 4 minus R squared. The square both side you get Z squared plus R squared equals to if you want to draw the full solid, you have to use the main one. So Z equals to 4 minus x squared minus y squared, and squaring both sides you get Z squared plus x squared plus y squared, which is 4, which is plus minus 2. So this is a hemisphere with radius 2. So if you want to draw hemisphere, I'm going to draw again. I'll draw the hemisphere. Negative part. This is x, y, and z. So the radius is 2. Okay. And then we have also here. Say I draw like this, and then I have another one from here to here. Okay. Okay. So then I have a cylinder with radius 1, but only the first part. Cylinder with radius 1. So I just consider this part. So because of the radius is 1, should be inside. Should be inside. Okay. So you can find your limit now. This is 0 to 4 minus r squared, 0 to 1, and 0 to pi over 2, z r dz dr d theta. So if you find this, so because this is just a EM1, so you will get 7 over 16 pi. So please check. If anything wrong, just PM me, okay? Just personal message to me. Give a personal message. Check and refer to me. Okay, 2b. They already give you the limit. Like the 1 to 1. And then 0 to 1 minus y squared, 0 to x, dz dx dy. Okay, this is just r squared. Dz will be remain, and this is r dr d theta. So this is r cube dz dr d theta. So now we have to change all of this. Okay, we have y is from -1 to 1, just a constant. Your x is from 0 to square root 1 minus y squared, so it can be a function or a curve. And then we have z is to be from 0 to y. Okay, look xy first. Easy. This is one of the way to find the limit of r, theta and z. So for y, -1 to 1. Okay, -1 to 1. And then we have x from 0, which means you have to start with only here, and always positive, so it should be some around here and here. Okay, then you have x equals to square root 1 minus y squared. It is positive, so it's just positive part. And then if you square both sides, you get x squared plus y squared equals to 1. So it's a circle, but we want x is more than 0, so we just consider here. Okay, it's a circle, should be circle, but it's semicircle. Okay, okay. You can find the limit for r and limit for, we call the bounds theta. So limit r for sure is 0 to 1. Everywhere is 1. No problem. Now for r. For r, we don't want xy. For theta, sorry. So your theta, if like this, I have taught before. Your theta should be negative pi over 2 to pi over 2. If it is like this, it is negative pi over 2 to pi over 2. Actually is here, and another one is here. So the whole thing will be negative pi over 2 to pi over 2. So now z, how about your z? So you have 0 to y. What is y? Y is r sine theta. So done. Your z is between 0 to r sine theta. So our purpose is we want to change the rectangular coordinate or non-rectangular coordinate to polar coordinate via the cylindrical coordinate. So your integral now is negative pi over 2 to pi over 2. Your radius is 0 to 1 and 0 to r cos theta. R cube dz dr d theta. So I'm sure you can find this, and then you will get 205. Okay. The hardest thing is you have to know how to find the limit. It's the main thing. The others is just a calculation. Okay. Next question. Application cylindrical in a volume. Limits is not directly given. So let me try question 1b. They ask you to find the volume of the solid bounded by the given surface B. I just choose B. I skip the A. Z equals to x squared plus y squared. X squared plus y minus 1 squared equals to 1. Z equals to 0. Okay. So you want to use the cylindrical coordinate, just polar coordinate also. So we try to draw. Okay, what is this? So this surface represent the parabola. This surface represent the cylinder. Okay, but the radius now, the center is now not 0, 0. So we try to draw, and Z0 is just, you want to show that always start from the XY. Okay, start from XY. Z0 means X, Y, 0. Okay, in 3D. So x squared plus y squared, because that squared will be somehow so this, and inside is a circle. Okay, the same if you draw the negative part like this. Okay, this is x, y, and z. So another one is center at 0, 1. 0, 1. X0, Y is 1. So it is here. So this okay. So maybe the paraboloid should be more bigger. Okay, because it's infinitely many radius. Okay, nice. So this is x squared plus y minus 1 squared equals to 1. And then this is z equals to x squared plus y squared. So it is specific and radius. I just put the biggest one. Okay, from the circle we have 0, 1. Okay, always focus on xy plane first. 0, 1. Okay. Okay. Okay, so this is your base now. So from here you can find theta limit and r limit. Okay, theta from positive axis to here. Okay. so which is from theta 0 to theta pi. Theta is from 0 to pi. Now your R should be from the pole to the surface. So it is not from the center, it is from the pole and upwards. So we have to find this line. Okay, so to find this line you can use this equation. You have learned this in double integral in polar coordinates. So let's see, x squared plus y squared minus 2y plus y squared equals to 1, and then this is 1, sorry, then 1 minus 1 0, f x squared plus y squared minus 2y 0. Okay, this is r squared equals to 2y. Your y is r sine theta, and then cancel the r, will be 2 sine theta. So now your r from here 0 to 2 sine theta. Okay. So we already get all the limits now. Okay. Okay. So now your integration volume means triple integral 1 dv. So this is a cylindrical fluid. So r dz dr d theta. So your theta is from 0 to pi. Your r is 0 to 2 sine theta. And then your z is from 0 to r squared. Why r squared? Because they give you z equals to x squared plus y squared. So you just change to r squared. So you can integrate this. You will get (3 over 2 pi). So the integration is quite long. Try to integrate slowly. So another thing is, I'm going to share with you is, if the solid bounded by the given surface, okay, we already have z equals to x squared plus y squared. We have x squared plus y squared, y minus 1 squared equals 1. Z is 0. What does it mean? If I cut this, you will get okay. Somehow you will get like this. So actually you are finding this volume. Okay, I just choose, so if I draw here, and sorry, I have removed this, back. this part. Okay. So we have another example, A and C. So A and C will be your homework. Application slide 31. Example 1, question 1 will be your homework. Question 1A and 1B for application. 1C. B already done. Okay. Homework. Okay, that's all. Goodbye and see you again.